Okay, on this video we are going to review multiplication and division of powers. So let's start with multiplication. So we're gonna multiplying with powers. Okay, so let's review big number. Okay, is called base. And remember that big for big. Big number is the base. And the little number right here is the exponent. So the exponent 5 tells me that the base will be multiplied by itself as many times as the exponent says. So if there's a 5, I'm going to multiply 3 times itself 5 times. Okay, so that's how you expand. So if we have 3 to the second times 3 to the fourth times 3 equals, we can expand right here. And as you can see, you have 3 to the second is 3 times 3. 3 to the fourth is 3 times 3 times 3 times 3. And 3 to the, we don't see the power right here because it's invisible, 1. So that will be 3 to the first power is 3. Then we count 1, 2, 3, 4, 5, 6, 7. We have 3 to the 7th power. So for multiplication, we're going to write here to the side. When you multiply same bases, in this case, the base is 3. See, this base is the same as this one, and is the same as this one. So when you multiply same bases, what do we do with the base? We're going to keep the base, and what do we do with the exponents? We're going to add the exponents. So make sure you have that in your notes. So when you multiply same bases, let me highlight that for you. When you multiply same bases, you keep the base and add the exponents. So that is the rule for multiplying powers. So now that we know that, we can skip the step right here. This is what we call expanded form. This is what you do when you want to prove to anyone why is your answer 3 to the power of 7. Once you get used to do that, you can skip the step of expanding, and then you can apply the rule. So let's say you have x to the power of 4 times x to the power of 3 times x to the power of 2. So here we have multiplication of same bases. So the rule says keep the base, and add the exponents. So we're going to add 4 plus 3 plus 2, and 4 plus 3 is 7, 7 plus 2 is 9. Pretty simple, right? So now, if you could have negative exponents, we have talked about negative exponents in class. You might turn it into positive, but I'm going to show you now something that actually, if you remember this rule, when you multiply same bases, keep the base and add the exponent, you could use that and apply it to any problem, regardless what the exponent is. So let's say you have x to the power of negative 3 times x to the power of 7. Okay? One more time. You're multiplying and your bases are the same. And the rule says keep the base, add the exponents. So we have negative 3 and positive 7. So that will be negative 3 and positive 7. Following the rules for integers, we get positive 4. We subtract because the signs are different. Keep the sign of the highest absolute value. Okay, so let's try another one. Let's say you have x to the 4th times x to the negative 9. One more time, we're multiplying. I don't know why this is not listening to me. All right. We are multiplying same bases. You see that? We're multiplying same bases. So we keep the base and we add the exponents. So we're going to add the two exponents. The base is x, and 4 plus negative 9 is negative 5. Now here you have to make sure you understand that when your answer has a negative exponent, you should be able to write it either with a negative exponent and also be ready to write it with a positive, because sometimes they're going to say keep your answers with positive powers. And we learned in class that in order to write a negative power as a positive, you write the reciprocal. So this is standing on top of 1 if we write it as a fraction. So to write the reciprocal, all you have to do is put this down as the denominator, and the power becomes positive 5. So you could write your answer like this: 1 over x to the power of 5 or x to the negative 5. Please understand that these two right here are exactly the same. They don't look the same, but the value is exactly the same. They're equal. Okay?